this is Himabindu from the Department of CSIT. So today in this video, I would like to explain about the pushdown automata. So pushdown automata, what is the representation, graphical representation of this pushdown automata, and acceptability. So how we are accepting the strings like empty stack or final stack acceptability. So in previous videos, we discussed about the pushdown automata definition and how to what is the identification and instantaneous description and turnstile notation. What are the terminologies which are involved in the construction of pushdown automata? So today in this video, what is the acceptability and representation, graphical representation of pushdown automata we will discuss. So here in the previous video, we already discussed what is meant by pushdown automata and what is the definition of pushdown automata. So here the 7 tuple notation. So here in the finite automata, we discussed about the discriminate finite automata and non-discriminate finite automata. Those are all having the 5 tuple notation, and here in the pushdown automata, we have a 7 tuple notation. So there is a difference between the finite automata and the pushdown automata. So we have two symbols are added, two tuple values are added here. So what are those in the sense? One is the tuple, say stack symbols, and here Z0. Z0 is the initialized stack symbol. So these two are involved here. And here we will discuss the states. Q is nothing but a finite set of states in the DFA, and here the states of epsilon NFA, non-discriminate finite automata. And alpha. So here the sigma, which represents the input alphabet. So here what are the string values which are like 0 binary numbers or alphabets which are involved in the input string. So those are all named as alphabets. And here the stack symbol. So while constructing a pushdown automata, we have to maintain a stack. In that stack, we have to push the input alphabets, and those are all named as stack symbols. And transition function. So here transition function which involves the top of the stack value and what is the input we are inserting into the stack. Those are all called as transition function. And here the Q0 is the initial state, and Z0 is the initial stack symbol, top of the initial stack symbol. We have to insert this into a stack. And next, F, finite set of states. So here the final accepting state. So here the string in the pushdown automata, when we are giving the input to the machine, that it is going to be accepted or rejected. Those are the two states we have to maintain. So for that one, we need this final state is required. So that named as an acceptance state. And this is about the definition of pushdown automata. And here the graphical representation, state diagram of pushdown automata. So if you observe, this is already we discussed the ID representation, that is nothing but instantaneous description. So in that one, these three values are already discussed. This is a triple notation. So triple notation in that one, first one is the state, the current state, and A is the input symbol and X is the top of the stack symbol, and next QZ is nothing but here the next state, and Y is the after operations like push or pop operation which was done by the pushdown automata. So remaining all the things which is value of Y. And here we will discuss. So here the graphical representation. So we are taking the two states here. This QI and QZ are the two states we are taking. And here we are giving the input symbol A as an input symbol. On top of the stack symbol is X. So and Y is after operation performed by the stack values like push or pop operation. What is the left thing is like Y value. And when we done a push operation, the input value is added to the stack symbol. And when we pop operation is done to the stack symbol, that value is not there in that stack symbol, and remaining stack symbols are all involved in the stack. And QZ, so when we give A as an input to the Q1, Qi, and it is reaching to the QZ with the push and pop operations. So here this is the graphical representation, and we will discuss this is QI is nothing but it is a current state, and A is the next input symbol. So suppose here 001 is there. This is the string. We have to construct a push down automata. So first string we have to take, and we have to give Q. If suppose this is an example of PDA. So here the zero, well, first zero we have to give for the Q naught symbol, and top of the stack symbol is Z naught, and if based on the language, the push and pop operations are decided. So here 0 is there, and top of the stack symbol is Z naught, and here what we have to do, push operations, so that it is Z naught included, and here the Q1 is the next state. So like that we have to construct a push down automata. We will discuss more with the examples how to construct a push down automata. And so this is the representation, and here the input next symbol is like this. Whatever, after reading or after consuming all the input symbols, it is reaching the empty. So in that case, how to react in the stack symbol we will discuss. So these input values are all in the next input symbol, and next X is the current stack top. So whatever there in the current stack. So here in this case Z0 is the top of the stack symbol. So Z0 is the top of the stack symbol. So we can say that here for this example top of the stack is Z0, and next the stack top replacement Y string. So here replacement, in this case this is the this is the Y value. So Y value is nothing but after push operation this 0 is included into the stack. So that value is named as a Y here. So this is Y, and the next state, so this named as the next state. We are giving this input to the next, we are giving this input value to this current state. It is reaching the next state. So this is the transition diagram or state diagram for the push down automata. And here the transition function. So we discussed about the definition, and definition it is having the 7 tuple notation. The two extra symbols when compared with the finite automata is the top of stack symbols and tau stack symbols, and Z naught is the initial top of the stack symbol. Those two are the input values which are additionally added for the finite automata. And coming to the transition diagram, transition function. So how to write the transition function for the push down automata. So here if you observe this is the transition function. We already written the finite automata. So transition of Q naught, and we will give some value. 0 as an input, and it is reaching the Q2. So this is about the finite automata. So finite automata. So like that, here also we have to write the transition function. How to write this transition function in the sense, the Q is a epsilon non-deterministic finite automata states. So here the Q, cross, and sigma. So sigma which contains the input stack symbols, and top of the stack symbols tau already discussed, and this leads to next state. So here it is the old state and the next state. This is named as the new state, cross tau symbols. Based on the language, these values are going to be changed. Either it is a push or pop. And here this is the Q here left side of the Q is nothing but it is a old state, and here this is the example. Here we have a Q, this is the old state, and this is the new state for the input A. So here the input symbols which was taken from the sigma, and tau is the top of the stack symbols. And here we will discuss the transition of QAX. So A is the input which was chosen, input symbol which is chosen from the sigma. Suppose here 0, 1, 0, 0, 1, 1. So this is the string. So in that string, we have so sigma value is equal to 0, 1. So in that one, we have zeros and ones. So first string is 0. So how to choose this string in the sense? So here the A value is which is chosen from this left to right. So here the A value which is belongs to the string starts to end. String consumption. And next X is equal to here what we already discussed in the previous slide. So X is the top of the stack symbol. So X is the top of the stack symbol. And next, so here the state, so state transition from Q to P. So this is the transition from Q to P. A is the next input symbol. So what is this A? Here the A value is equal to 0. A is the next input symbol and X is the current top stack top symbol. So X is the current stack top symbol. And Y is the replacement of X, we already discussed, and it is in tau star. Tau star is nothing but it is a turnstile notation of multiple IDs. So multiple IDs. So this triple notation is represented as ID, instantaneous description. So moves from one ID to multiple IDs named as this tau star. And next, a string of stack symbols. So here the tau star is nothing but a string of stack symbols. So here based on the situation, the Y value is going to be changed. So here the set Y is equal to epsilon. So in case here after consuming all the input symbols, suppose Y is equal to only epsilon is there, this X pop operation is done. And next, Y is equal to X. So in case of any value is there, we have to stack top is unchanged. So value is there, we have to unchange that stack. And if Y is equal to Z1, Z2, Zk, so here the X is popped and replaced by Y. So here based on the push and pop operation according to the language. So language wise we have to done the push and pop operations onto the stack. So this is about, and here we will discuss what this discussed. Y is equal to epsilon, we have to pop the X. And what is that X in the sense? The X value is the top of the stack symbol. And here the Y is equal to X, the same value is repeated. So we have to pop and push operations to be performed. And Y is equal to Z1, Z2 and Z up to Zk. We have to pop X and push K1 and push Z K1, K2 and K3 like this. So we have to do the push and pop operations according to the given language. And here this stack which is converted. So initially top of the stack symbol is X here, and after the push and pop operations done, the Y is replaced onto the top of the stack symbol. And this already discussed. So here this is the transition function. So transition functions which involves the 3 tuple notation, and in that one, first one is the Q. So Q value and input symbols and top of the stack symbol. So this is about the transition function of the pushdown automata. And here what is pushdown automata? Pushdown automata, there are 2 different ways to define the pushdown acceptability. Pushdown automata acceptability. First one is a final state acceptability and second one is the empty stack acceptability. So here the final state acceptability is nothing but after consuming all the input symbols in the stack, whenever it is reaching the final state, so it is named as a final state acceptability. So if in final state acceptability, a pushdown automata accepts a string. So after consuming all the input string, it accepts a string. When after reading the entire string, the pushdown automata is in a final state. And next, from the starting state, we can make moves that end up in a final state with any stack values. So here the stack values are irrelevant. So how many stack values are there? that is nothing with the construction of pushdown automata. So here, how many states, how many stack symbols are there in the stack, that is irrelevant for the final state. And here, if for the pushdown automata, we already discussed this. It is a 7-tuple notation and how to further accepted for the given language. So here, for PDA, we have discussed the language that accepted by the set of final state F is. So here, so the language for this final state acceptability. So here in the final state acceptability, we have to maintain the word is nothing but here the string which was constructing for the given language. So given language is having many strings. So in that string we have to take one string that is named as word, and this triple notation we already discussed. This is the current state and we have to start from initial state, so that so q naught comma w is nothing the word which is unconsumed, and I is nothing but here the top of the stack symbol. And turnstile star is nothing but multiple moves from IDs. So ID moving from one ID to another ID, that is nothing but from Q0 to Q1 and Q1 to Q2, like this there is a moves. So these are moves are named as the IDs, instantaneous description. So how many moves are there in constructing this PDA for this given language? Those moves are named as here turnstile star. And here this is the initial state and this Q is the final state. So why? Because so the acceptability is given for the final state. So Q here after all the last state is the final state, and here final state it is having the empty stack symbol, empty string, and X is the top of the stack symbol, and Q is nothing here the empty stack, input stack. So whatever left in the input stack, so those for any input stack string. So here this is the string, and here the Q is nothing but here this Q value is differ from empty stack acceptability to final stack acceptability. So here the Q is which is a final state acceptability. So final state. So here the Q which is belongs to F. So this is about the final state acceptability. Let's move to the empty stack acceptability. So here empty stack acceptability, here a PDA accepts a string when after reading the entire string, the PDA has emptied its stack. So previously we discussed about the final state acceptability. In that one, the string after reading the stack should be in the final state. And here the stack should be in a emptied its stack. So empty. So we have to empty that stack. And here for PDA, so this 7-tuple notation for PDA is common for either it is a final state acceptability or empty stack acceptability. And here for the given language, how to construct a empty stack acceptability. So here the Q0 we have to move starts from Q0 and W, so which is unconsumed input, and I is nothing but at the top of the stack symbol, and turnstile star is nothing but how many moves are there, like ID from ID to ID. So ID from Q0 to Q1 and Q1 to Q2, like that how many moves are there, those are all named as a instantaneous description. So those are combined together we will name as a turnstile star. So here if you observe previously we have a X value, and here if the value is changed to be empty stack, empty symbol, so that is nothing but epsilon. So whenever reaching the Q and it is having the empty, and stack is also get empty, and this Q is belongs to Q here, capital Q, so which was chosen from the final set of states. So that is the final set of states are also epsilon NFA states. So here, so Q which is previously we discussed, so Q is a subset of Q belongs to the finite state, and here Q belongs to capital Q. So that is the difference. So in final state acceptability, we have after reading or consuming the input string, it should reach the final state in the final state acceptability. And here, after reading and consuming the input symbols, the stack should be emptied. That is the difference. And here this is the example: 0 power n, 1 power n greater than or equal to 0. So this is the language. For this language, we have to construct a empty stack acceptability pushdown automata. And here two final states are there, and Q1 and Q4 are the final states. And initially we have to give a initial stack symbol, and later, after giving for this 0 power n and 1 power n, if we insert 0 into the stack for 0 input symbol, and we have to pop when the input string 1 comes, we have to pop the 0. So like this, here we constructed a pushdown automata. We will discuss these examples more in the next videos. So these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.